I'll start from a bit introducing myself. My name is Vitalii, and I am senior Scala engineer at EWA. We are developing a payment system for e-commerce in Ukraine. So we are using Zio, Akka, Kafka, event sourcing in our project. It's large scaled in Google Cloud using Kubernetes. So in general, I am functional programming enthusiast. I like DevOps and I like to automate everything. And I'm trying to participate in open source projects. And actually, the library I'll show for you, it's an open source project developed by Tinkoff Bank. It's one of the largest online banks in the world. A little introduction about the library. It's called Phobos. Phobos is a Greek god of war. It's one of the Mars moons. And also it's an efficient and expressive XML data binding library for Scala. I have shared the link in our Slack channel, so you may try it. We used it in production. It's very great. It supports Scala 2.12 and 2.13. It provides you case type classes for coding and error code encoding XMLs from case classes and other data types. It provides a monadic API, auto derivation for codecs for case classes and sealed traits, and it allows configuration like Macquarie does, like Cersei does, for instance. Before we get started to my talk, I'll provide some scales for everything I'll compare. The first one is a Butford scale. It describes how much pain this feature brings to you. The second one is fear scale. It's, for instance, when you look at any library that's written with shapeless, you feel fear. Then happiness scale. It's every library that makes you happy to use it. For instance, Chimney for transforming case classes, it's very easy. It doesn't have shapeless. So I feel happiness when I use Chimney. And this picture for situations when nothing changed, actually, comparing Scala 2 or Scala C. Is it clear?
Yep.
Yeah. Okay. First, I'll show you an example using Phobos. As you can see, this is the case class. To use Phobos, you should annotate the case class or sealed trait using special annotations, which are implemented using Scala macro annotations. They will automatically generate codecs for case classes or traits and put them into companion object. Then you can simply summon them using the apply method of the type classes object companion and just use it. Additionally, you can provide some kind of configuration. In this case, it says that all the fields of case classes, no matter they are attributes or elements, they should be named with camel case style. Okay, let's go back. So macroses, it's a bit scaring, but it's finally painless API for XML in Scala. As I remember, there was only Scala XML, which doesn't provide mappings into case classes, and one library which works strange. Comparing with them, Phobos is very great. But because of IntelliJ IDEA, as you can see, in previous slides, it's red in some cases. For instance, when you're trying to summon the implicit codec, because of macro annotations, IntelliJ IDEA doesn't figure out what happens, and it's always red. It's a bit painful, but you can live with it. So let's try to rewrite it to Scala 3. And spoiler, how it looks like. Actually, almost nothing changed. As you can see, macro annotations moved to the end of the case class definition using the derives keyword. It's something like Haskell has. So instead of using macro annotations, you just use the derives keyword, and you should list all the type classes that should be derived for your data type. Then, because of improved type class syntax, you could use just dot syntax and call encode method directly on the case class instance and just use it. Actually, almost nothing changed, but let's go further. It's an example of implementation of this library in Scala 2. First you see is macro annotation and Scala reflect macros import. And the first impression is, no, God, no. It's totally impossible to debug. In Scala 3, something more simple, but one another dollar sign. How much dollar of Scala will have? I think it may happen that dollar sign will be as used as the underscore. Let's go deeper. No. We should cover some basic principles before we get started into the implementation of codecs in Scala 3. First, let's go back to the plain old Scala implicits. In this case, we have few examples defining encoders for basic Scala data types, such as strings, booleans, characters, and so on. This is how it looks like in Scala 2, and this is how it looks like in Dati. The main difference is that new given keyword, we use as instead of 2 dots. Instead of this one, we use as keyword. And in other cases, it looks the same. So the first impression is I'm not impressed. But let's compare inductive implicits. Inductive implicits is when some implicit def depends on only implicit values. So it behaves much like just plain implicit values. In this case, it's a definition of an option encoder. It says when you have an encoder of some data type A, you could easily implement an encoder for option of this A. And in the implementation, we just delegating all the work to the element encoder of type A. Pretty simple. In Scala 3, much the same. Instead of implicit def, we are using given. Instead of implicit parameter, we use using. And in other cases, much same. But this is given contextual abstractions has more difference. Firstly, anonymous given instances. Sometimes it may be very useful, but the first question you could ask is how to import them without using underscores. And I'll answer later. Firstly, I want to point your attention for the new type classes syntax. Does anyone use type class annotations from simulacrum? Or just seen it, for instance, in cats?
Seen, but never used.
Yeah, okay. So the main idea of type class annotation is that you annotate your traits, which may contain only a single type parameter. Then you write simple Scala code, and special macros from simulacrum will generate companion object with implicit classes providing syntax support for your type classes. So by default, Scala doesn't support such auto generation, but .t does. To do that, you should use this new, a bit strange syntax, but it works well. This means that the A variable of type A is some kind of this instance, and then dot encode. It means that this method can be called as this function may be called as one of the methods of type A if given instance of XML encoder. So as you can see, within this type class, I'm using this encode to bytes function using dot syntax. So it works pretty well. And when we have an encoder for our bar case class, we can use the encode method. Is it clear? If somebody has some questions, feel free to ask. Okay, let's go. What about recursive implicit resolution? In Scala 2, it doesn't work by default. Probably somebody have seen lazy in shapeless. It's a special data type that provides lazy implicit derivation. In Magnolia, for instance, it's called deferred, and it requires special usage within the macros. In other words, something like this. What about Scala 3? We need absolutely nothing because it works out of the box. I will show some examples at the end. Then given imports. Let's imagine we have some kind of library providing 4 kind of given instances, some context, some contextual stuff, codex, and monoids. Let's say we have those given instances in object called my library. We have context, contextual stuff depending on given context, codex and monoids for ints and strings. Then, how does new import syntax looks like? Import cats implicits won't work in Scala 3. in the newer versions. In current version, it works because currently Dati supports both new given syntax and old implicits. So currently you can import cats implicits, but let's imagine cats are rewritten using new contextual abstractions. So in the new imagined version of cats, you cannot just import my library underscore. You should explicitly say that it's a given import. Then you're allowed to import, in some cases, just using the value or the function name. But in my example, I am importing using types. So let's say that we want to import given instances of type context. We want to import given instances of codex for strings, and we want to import any given instances of monoid. And as you can see, summon is a new function like implicitly in Scala 2. So we are able to summon context, codex for string, just for string, and any monoid. Here we can see that contextual is not allowed and codec for int is also not allowed. So looks pretty fine. It's some kind of self-discipline for developers when using such powerful libraries like cat or any other. And when you want to import all the given instances, you may just write import my library dot given and underscore. But yeah, looks much same as import cats implicits, but when you just use my library underscore, no given instances will be imported. So it's a bit safer, I think. If anybody has some questions, please ask. One, two, three, let's go. There are also features that not covered here. It's context functions. It's special lambda. Few words. It's previously it was called implicit function. The actual syntax is something like, it means that it's a function that takes one given parameter of type A. Implicit conversions was made more safer. Now there are no given def that takes explicit parameter and which can be applied when types doesn't match. Now you should use special implicit conversion trait. So yeah, implicit conversions made a bit explicit. Also, Scala team have improved resolution algorithm of implicit resolution. It works a bit different than it worked in Scala 2, but yeah, it's improved. So the verdict is 3 happy cheers for all the new features and improvements, but 1 bad chord because you should rewrite implicits to givens. So let's go. I'm sure that everybody heard about delegator pattern. This is how it looks like in Scala 2. Oh, sorry. we have some instance of an interface, then the class, in this case Phobos Sim Writer, extends the same interface as it wraps. In most cases, we re-implement some methods, but the rest of the methods is just delegating the method call to the underlying wrapped instance, like here, here, here. In IntelliJ, you have a special icon for those stuffs. But there may be a lot of methods. Very lot. I skipped some methods. Sorry, can you repeat? Oh, okay. Yeah, as you can see, we have over 200 of lines of code of just delegating the function call to the wrapped underlying object. And it's totally painful. But in Scala 3, we have a special export keyword. Export is dual to the imports. It says that, in this case, export says that the Scala compiler will take every method from the underlying object CW and override it, delegating the function calls to the CW object, all the functions instead of except of this one, because we used instance arrow underscore syntax. It works the same as in imports, so that we can just export everything from the underlying object instead of those functions we want to override. We just override them, and it's 20 lines of code instead of over 200. Yeah, it's very helpful, but you often may hear that explicit is better than implicit. So sometimes your team lead will ask you to explicitly write all the things you want to export. But it's much better than over 200 lines of code. Few words are new significant identification syntax created by Martin. So my first impression was it looks not bad. Let's see some examples. For instance, in Scala 2, we should use curly braces, but here we just write 2 dots, and then everything is separated using spaces or tabulations. Optionally, at the end of any definition, in this case, at the end of the class definition, we can optionally put and in the name of the definition. In this case, it's the class name. In most cases, it's not needed. But when you use local functions or local classes, it may help you to visually separate one definition from another. Yeah, and currently both old syntax and new syntax are supported. And Dati provides an automatic tool for converting old syntax to the new syntax when it's possible. As I remember, it's a special command either in the Dati compiler or in the SBT plugin. But 100% that there is an automatic tool. So then Yeah, I haven't covered new enums because I just used them in one case, and I have nothing interesting to talk about. Yeah, in this case, underscore is even used to create anonymous instances of traits. It's used in new enums. And when you, for instance, create local classes, in this case, we have a class, then it defines an other class within itself depending on this public value. One more definition, and optional ends. Somebody can say that if we replace two dots and it will become, with braces, it will become plain old Scala 2. Yes, but as I said, ends are optional. So you may just erase it, it will work. So personally, I'll recommend using end just in case of local functions, local classes. In other cases, you can simply read the new code without the end. But you still should use braces in imports, in exports, and unfortunately, in cases when you use pattern matching there directly instead of partial function, like in collect or collect first function. Sad but true. And my verdict is, for somebody it's cool, for somebody it's disgusting, but we should try it, because OCaml, Haskell, F#, very functional languages. Scala was inspired by OCaml. They don't have curly braces, they use tabulation, so let's give a try. Next, let's talk about new macroses. One more $sign, but let's cover some details. First, it's new inline keyword. It means that this piece of code will be injected directly into code, which is calling function assert. It's not inline annotation, which is present in Scala 2, because inline annotation means that it can be inlined or it may not be inlined. It depends on the code you have written. But in this case, it's 100% will be inlined. Then the inline keyword may be used before the function parameters. It means that value of type expr should be only compile time literal. For instance, you may call assert with only true or false. You may not, you cannot pass any value of type Boolean, just plain literals. Then, as we can see, assert itself delegates the function call to the assert impl function using this special $sign and quoting. New Scala macro, it's much like macro assert impl in Scala 2 macroses. The meaning is the same. but there are a few differences. First is that any macro function requires a given instance of quote context. It's something like black box or white box macroses, or execution context for futures. It's required to use quote and curly brace and dollar injection. It's called quoting, and dollar before the curly braces, it's called splicing. It's dual operation. Quoting allows you to create an expression of any type A or a type of any type A. And splicing allows you to extract the value of the expression and of the type. But the splicing can be only used within the inline function. Within the inline functions. Then, as you can see, one macro function may use the other macro function. In this case, the first $sign is string interpolation. The other one is splicing. And here we have some more macro code. And it works fine. Any questions about this? Okay, let's go. One important note is that new macroses are type checked and safe, so you cannot produce abstract syntax tree which is not valid. They have a great IDE support. For instance, when you write incorrect new macroses in Visual Studio Code, the IDE will make your code red when something goes wrong. So it's type checked, safe, and IDE friendly. But it has one more disadvantage, which we'll cover later. So let's talk about Tasty. Tasty is a special intermediate format of your Scala code. It's probably like Java bytecode because it's an intermediate layer between the actual your actual Scala code, Scala 2 code, Scala 3 code, starting from 2.13 version of Scala. Your Scala code is compiled into Tasty format. Scala 3 code is also compiled into Tasty format. Then Tasty format is used by macroses, any optimizers, by, for instance, IDEA or VS Code. Then the Tasty format is compiled directly into Java bytecode for any Java version, for JavaScript, or for instance, LLVM for Scala native. So it's pretty helpful, I think, because finally tooling for Scala will become good. Then it also allows to import any library, compile it against Scala 2.13 into Dati. We should use special with Dati compat method in SBT. So in my case, I can import cats into our Phobos library, rewritten in Dotty, and use it very well. So it's a success. Thank you to Tasty. Let's talk about the disadvantage of new Scala macros I taught before. This is an example for the Tasty reflect. As you can see, the quote context we used before for macroses has a value called Tasty. When we import everything from Tasty, we are allowed to call a special method called unseal on expressions and types, which allows us to explore all the abstract syntax tree under this expression. In plain old, in the new Scala macros, we can only pattern match against this expression. It's a bit safer, but also new Scala macros doesn't allow you to dynamically create abstract syntax trees. So in cases like mine with codec generation, when I need all the meta information, including annotations, subtypes for sealed traits, field names, new Scala macros is not an option for me. Is it clear? Yeah. Okay. And one more interesting thing about Tasty, import quant context Tasty is something like Alice in the in the Scala reflect. Yeah. But it looks pretty familiar. Quote context, taste, import quote context Tasty, and here we go. This is an example of Scala 2 black box or white box macroses. So the design under the Tasty reflect, it's much the same as in Scala 2 macroses, but abstract syntax trees in Dotty have been changed a bit. So it's not the same, but looks familiar. Then let's go back to our implementation. Yeah, because there are no type projections in Dotty. In this case, the example could be quote context sharp type. This isn't supported in Scala 3. We can use only path-dependent types directly. So it's a bit painful to describe some kind of helper classes. Like in this case, I have a case class describing all the required meta information about case class fields. Because of absence of type projections, I should write wrappers for the quote context and then define all my helpers within this class. A bit painful, but we can live with it. Then, using this magic import from the quote context, we are allowed to use functionality much same as Scala 2 matrices. For instance, having an implicit, yeah, this type is Scala quoted dot type. And the type of provides an instance of Scala tasty reflection type. The difference is that Scala quoted type is a type constructor, and tasty type is type without type parameters. Also, this quoted type is something like a black box. You just know that you can inject an instance of type of some A into quotes. In case of tasty type, it contains all the required information about the definition of this type. Yeah, you have extract. You can figure out, is this class or a trait? You can iterate over fields, its annotations, and so on. Yeah, it's another example from the implementation, but it's a bit painful because tasty reflect has no quasi-quotes, and we should pattern match against the AST directly. Okay. Also, tasty allows us to construct AST. It's one of the examples of creating the actual codec. Yeah, still no quasi-quotes, and we should construct the AST directly, and it's more painful. But in the end, using a special method seal, which is dual to the unseal, it allows us to create an instance of quoted expression instead of some piece of IST. And then we can inject those created ASTs into new Scala macroses, and it works fine. It's not as type checked as just using new macroses, but it allows us to manipulate abstract syntax trees. And in my case, it allows all this stuff to work. Yeah, as I said before, implicit given resolution in Scala works, in Scala 3 works better than in Scala 2. So we can use this case class definition as one of fields in the same case class. We can simply construct it. Using the derives keyword, we can derive all the required encoders. And as you see, it works fine. It picks the full name of the class. Oh. It gets all the field names, taking renamed annotations into account. In this case, subname becomes an attribute here. So yeah, it works pretty well. It compiles fast. And I'm happy that Scala 3 becomes more powerful, more like balanced, more functional, and so on. So it's very happy. Yeah, you may try the Scala 2 implementation of Phobos library. You may look into my version written with Dati, and it's me on the GitHub. Yeah, thank you for listening.
Are you trying to port to Doti something from work?
Actually, this is the first library I'm trying to port. Because almost all needed stuff already works because of tasty compatibility. Probably it's the first project because I already contributed into it. So I know the code base a bit, so I can migrate it easily. And it has macros, so now I know the approach, because before starting I thought that inline methods and new compile time mirrors will be enough to implement codecs. But on the practice, I needed the whole tasty reflect. Yeah, have I answered?
Yes.
Okay. Yeah, actually, I can share the screen and show some code. So actually, some interesting parts that I haven't covered in my presentation. Yeah, I used the latest Dati version. Yeah, probably I shown that I'm able to use the latest CATS version, which is compiled across Scala to 13 using this special method. The same with, yeah, Scala tests should probably work in some cases, but probably some macro-dependent stuff like highlining and the stuff when Scala test shows the difference between two strings or prints the whole expression which failed. This may not work. Yeah, then yeah, one more thing about the new syntax is that yeah, in this case, in regular Scala, we should write this in this manner. But to write with two dots, a special compiler flag is needed, which is called ident columns. So yeah, probably this feature is more like is more experimental than the whole idention syntax, but I think looks nice. Yeah, and one more note. Currently, I've ported only encoder derivation, but not the decoder one, and without sealed traits, just regular case classes. So there are still a lot of work to do. And probably the most interesting stuff is to port, no, not port, but is to implement codec derivation for new enums.
Why somebody who need to learn Scala need to learn three different things? It is expressions, incantations, and macroses, then derivation. This is three different things which describe one model. It's comment, yes.
Yeah.
So looks like so you need to memorize three interfaces, but only when in general, no, in theory, this should be one interface, I guess, in the ideal language. What do you think?
Yeah, it's a bit, I think, complicated, especially for newcomers. The actual problem Ruslan pointed is that to support derivation in this manner, like in Haskell, just derives and the actual type class. Library maintainers should firstly remember that the type class object companion should contain given derived method, which should be generic. In some cases, it's the single entry point, so you can put the actual implementation here. For example, if you are implementing show type class, we can do its naive implementation. So, but we are still, oh, sorry. Yeah, actually, you could just put implementation here, and in cases when, for instance, if you are using monoids, you can just use. Yeah, if you are trying to implement monoids derivation, you could just use Scala compile time package. Then let's left it. Then yeah, probably not this one. Yeah. What's wrong? Probably something. Yeah, I haven't started the IDE. Yeah, one annoying thing in developing using Visual Studio Code is the requirement to execute launch IDE command before you starting writing the code. Yeah, this is because Scala developers, the developers of the Scala integrated language server protocol, so that IDEs can use it for warnings, errors, and completion. But in this case, it doesn't work unless we launch this command. I may describe in few words what we are doing. We are developing a payment system for the rest of our products, which contains, for Ukrainians, you may know Rosetka and Prom. Also, probably our payment system will be used for Prozoro.
Rosetta is analog of Amazon, Ukrainian, yes?
Or Chinese Alibaba.
Yes.
If I pronounce it in the right way. So yeah, we have a lot of services. I'm developing currently the one which is responsible for limiting the operations according to configurable rules. For example, no more than 200 hryvnias per day for this type of operations. Which this service is fully implemented using Zio, Dubi, Avro, because of the dynamic nature of operations and the rules. for some reasons HTTP, but also we have service responsible for e-wallets, which is implemented using the same stack, but with HTTP4S. On the other hand, I'm also developing a service which is responsible for tracking balances of the accounts of the wallets. We are using ACK cluster with Lagom for event sourcing. Also, we are using in the same project Rabbit, Kafka, ACK actors and streams. Also, we have, mostly we use PostgreSQL as a database. I heard that we are also using ClickHouse. It's a column-oriented database. Elasticsearch, and a lot of more. I don't even know all the stack.
Yes, and just curious, why Kafka and Rabbit in one project?
I'll describe it using one example. In some of my projects, we used, for instance, Postgres to store relational data and Cassandra for big data. The reason we are using both Kafka and Rabbit is the same. We are using Rabbit for publishing subscribing because we benched that Rabbit pops up in most cases works better than Akka publisher subscriber. It has lower latency in 95% of our needs. Also, we are using Rabbit for messages with priority. Because Kafka doesn't support such things.
No, it support in Kafka. We can just do topic for priority, so we can make the same, but on the client side. But it's don't mind. It's just my comment.
Yeah, in RabbitMQ, it's just one additional header for the message. It's probably more easy. Yeah, and probably it's our main stack.
And are you in production now?
Yeah, as I know, our project works on Rosetka for at least 4 months, as I know. They actually support online payments. Yeah, and actually they just started a few months ago to using our payment system. As I know, it fits pretty well for them. And maybe 1 month ago, Prom has started to use our payment system.
And the wallet is on Lagon. Yes, it's on top of Cassandra.
Currently on top of Postgres because it's the most painful service. Currently, this service, which is tracking the balances, not only on wallets, also on the credit cards for merchants. It's currently running in, I'll say, just consulting the administrators because of the problems with with Akka cluster reliability and with split brain resolver. So that's why we visited the talk about lithium, because currently we're not using any split brain resolver, which is dangerous for production. And we may try it.
Okay. Interesting. And implementing such complex payment system from scratch, how long it will take? And interesting.
I joined the team in February, so I haven't developed it all from the scratch. But as I know, it's in development, probably almost 1 year.
No, it's okay. It's normal. It's okay. Quite usual. This call. I'm glad. Yes. And how? What you want to change in your stack, or what you? I guess what new things you want to adopt now, except the .3, of course, which will be not today.
Yeah, as I said, Akka cluster is our is our point of pain, and all the team agrees, but it's very costly to re-implement it from the scratch. But in some point in future, we may re-implement it. As I heard, Apache Pulsar may fit. It looks at least more reliable. Probably some non-relational database as our event sourcing data storage. Yeah, and as I know, we may implement anti-fraud system for the operations. Yeah, we have a special license from Visa and MasterCard for processing payments. And as I know, they require some kind of anti-fraud system between the client and their payment system. So probably we will adopt some big data processing engine with, yeah, it may be even some machine learning capabilities. So it will be very interesting.
It will be new approach.
Yeah.
Okay. Okay. Oh, good. So we are tired, but we are now on the time. Thanks for conversations. Yes, I guess we will speak later. Okay, we'll see you.
Bye-bye.